From chapter 4, I already discussed the basic of counting, permutation and combinations, binomial coefficient and identities. Next, I will discuss the pigeonhole principle. What is pigeonhole principle? Suppose we have 5 pigeon and we have 4 holes. These are the holes. Now suppose that 5 pigeon want to sit in that hole. Like let P1 will sit here, pigeon 1, pigeon 2, pigeon 3, pigeon 4. So 4 pigeons sit in 4 holes. Now 1 left. Where that pigeon will sit? It can sit with P1 or P2 or P3 or P4. Let 5th pigeon sit with pigeon 2. So that is all about pigeonhole principle. If there are more pigeons than hole, then in at least one hole there will be more than one pigeon. So here in this hole there are 2 pigeons. Theorem 1, it's about pigeonhole principle. If k is a positive integer and k plus 1 or more objects placed in k boxes. K is the hole and k plus 1 or more, these are the pigeons and they want to sit in k holes. Then there is at least one box containing 2 or more of the object. So let there are n objects, n is greater than k plus 1. So there are k boxes and n objects will fit in k boxes. So in at least one boxes there will be more than one object. The pigeonhole principle, also called as Dirichlet-Roth principle, as that mathematician use this principle very much. Pigeonhole principle which state if there are more pigeons than pigeonhole, then there must be at least one pigeonhole with at least 2 pigeons in it. If there are more pigeons and less hole, then there should be at least one hole having more than one pigeon. And this principle can be applied to anything beside pigeon and pigeonhole. So that pigeon can be any number of objects and that pigeonhole can be any number of boxes. Okay. Now this is a picture. There are 3 possibilities A, B, C. There are 13 pigeons and 12 boxes. In box B, in every box there are one pigeon. In just one box there are 2 pigeons. Whereas in picture A, here there are 3 pigeons, here there are 2 pigeons, and in some boxes there are 1 pigeon. So this can also be possible. In some boxes there is at least more than 1 pigeon. So more than 1 means it can be 2, it can be 3, okay? And here in picture C, here there are 3 pigeons, here 2 pigeons, here 2 pigeons, and in some boxes there are 1 pigeon. So that's all about pigeonhole principle, that in at least some hole there must be more than 1 pigeons. And in some hole at most 1. Here you can see some hole are empty. So there can be 0 or 1. So there are different possibility how pigeon can distributed in different holes. Now corollary 1, a function f from a set with k plus 1 or more element to a set with k elements is not 1 to 1. If there are more elements, then that cannot compare with k elements. It's not 1 to 1. Means in one hole there cannot be just one pigeon. There can be more pigeon. So it's not 1 to 1. Now example 1. Among any group of 367 people, there must be at least 2 with the same birthday because there are only 360 possible birthday. 1 year contains 366 days. And if every people's birthday is in different day, then there must be one people whose birthday crash with other people. Next example 2. In a group of 27 English words, there must be at least 2 that begin with the same letter because we just have 26 letters and we have 27 words, means at least 2 words start with the same alphabet. Next example 3. How many students must be in a class to guarantee that at least 2 students receive the same score in the final exam if the exam is graded on the scale from 0 to 100 point. 0 to 100 point means there are 101 point including 0. Okay, 1 to 100 means it will be 100. 0 to 100 means there are 101 point. And how many students will take that at least 2 students receive the same? So we need at least 102 students. If 102 students, then at least 2 students have the same point. So here answer will be 102. Next theorem 2, it's about generalized pigeonhole principle. If n objects are placed in k boxes, then there is at least one box containing n divide k objects. Suppose n equals to 11 and k equals to 5. We have 11 objects and we have 5 boxes. Then there is at least one box containing at least n divide k objects. 11 divide 5, its upper bound. Its upper bound will be 3. 5 multiplied to is 10. So 2 point something, its upper limit will be 3. There is at least one box that contain 3 objects. Till this we just consider one, but here there can be multiple. Okay. So one box contain at least n divide k upper limit objects. Now see one example. Among 100 people, there are at least 100 divide 12 upper limit. 100 divide 12, what will be it? 8.33. So 8.33, its upper bound, it's 9, who were born in the same month. There are total 12 months and we have 100 peoples. So how many people birthday can come in the same month? Suppose we'll divide equally, then every month 8 people birthday can come. There will be at least 1 month where 9 people birthday come. Okay. In today's lecture, I discussed what is pigeonhole principle with some examples. In next lecture, I will discuss some more examples. If this lecture is helpful for you, please like, share and subscribe. Thank you.